This is the graphing and transformations of trig functions. To start off our trig function transformations, it's a good idea to start off with the most basic sine function. The amplitude of this function is from this midline to its top peak, and the midline is the center function, which it can be measured as the average of the top peak and the bottom peak. As we see here, the function of the vertical shift is sine x plus k, and in this function down here we see that the midline is at 1, and you tell this because the average of 3 and -1 is a positive 1. And the amplitude of this function, which is the distance between the midline and the top peak, is 2 because it's 3 minus 1, I should say. And this is what the function looks like together. 2 times the sine of x plus 1. Let's see if you can state the graph that represents 2 sine of x minus 1. If you stated the graph on the right, you would be correct, as -1 is our midline, and the distance between our midline to our top peak is 2, as 1 minus -1 is 2. There's also horizontal shifts that move along the x-axis and are seen as sine of x minus h, and the period in this starting point of the function to the point where it starts again and is seen as sine of b times x. Remember that b equals 2 pi over the period. And here we can see our horizontal shift is pi over 2 because our function starts here. And the period is from here, our starting point, to where the sine function starts again in the same way. And we do 5 pi over 2 minus pi over 2, which equals 4 pi over 2, which equals 2 pi, and 2 pi over 2 pi equals 1. So our function looks like sine of 1 times x minus pi over 2. This is what all the different transformations look like together, as the amplitude, your period, your horizontal shift, and your vertical shift. Here are examples of the sine function. I give you a little bit of time to figure them out, but you may pause the video if needed. As seen here, the sine function is x, the sine of x plus pi over 2 plus 1. Since our horizontal shift is negative, we change our minus down here to a positive, as in 2 negatives equals a positive. And we see also that our vertical shift is 1. And for our right function, we see that it has a vertical shift of 2, and the distance between our center line and our top peak is half, so it'll be half times the sine of x plus 2. Now the cosine function is pretty much the exact same as your sine function. The only difference is the looks. The cosine starts at the top peak instead of like right here where the sine would normally start on the midline. Here are some examples of the cosine function. Remember that the cosine function starts at the top peak line. Alright, as we see here, the answer to this function is the cosine of 2 times x, because our period is pi, and so b would equal 2 pi over pi, or otherwise 2, as seen down here. And to our right function, we have cosine of x minus pi over 2 plus 1. Our horizontal shift, as seen, is pi over 2, and our vertical shift is 1. If you may remember, this was the first function I gave you in the sine one, the exact way it looks like. This is what the cosine function would look like if you use cosine instead of sine. And these is the transformations of trig functions.